Alrighty, welcome back again to Elementary Algebra. I am your instructor, Amy Fuchsteiner, and we are going to be working on slope-intercept form today. If you have had an algebra class before, this is the one you remember. We are going to be using the slope-intercept form to identify the slope and intercept on a line. We're going to be practicing how to write the equation of a line in slope-intercept form and using that slope-intercept form to graph a line. We want you to identify the slopes in parallel or the slopes in slope-intercept form to be able to identify parallel and perpendicular lines. And then lastly, we're going to do a little bit of application here so that you use the slope-intercept form of a line to model equations and data. Okay. All right, so we're going to use the slope-intercept form to identify the slope and intercept of a line, and then we want to be able to write it in slope-intercept form. Okay, so the slope-intercept form of a line is y is equal to mx plus b, where m is the slope of the line. That's the way that a line moves. That's what I tell myself. It's the movement of the line. The m is the way the line moves. And b is the y coordinate of the y-intercept. Okay, b is that y coordinate for the y-intercept, or 0b. The B is where we can begin. Remember, we practiced in 3.4, we practiced if you get a point and a slope, you can graph the line. So in slope-intercept form, we can identify the slope and we can identify the intercept, the y-intercept. So I have some things here that I hope will help you sort of figure it out. Okay. If we are looking at this first graph, I want to find the y-intercept of this line. The y-intercept of this line is where this line crosses the y-axis. So that y-intercept is at 0, 1. My y-intercept is 0, 1. Right? The slope, or the way the line moves, is the comparison of its fall. Right? So we go down 1, 2, 3, 4, 5. So we went down 6, and then we went over 3. So that slope is a negative 6 over 3, which is a negative 2 over 1. This tells me where the B is. That's my 0B. And this tells me where the movement is. The equation of this line in slope-intercept form is y is equal to the m, negative 2 over 1, times an x, plus the b, or the y-intercept, the 1. If we're going to simplify it a little bit, it's y is a negative 2x plus 1. Okay, note what the slope was and where that lands in the equation. Note where the y-intercept was at 1 and where that lands in the equation. Okay, in the second one, we need to find the slope and the y-intercept. The first thing I've asked for is the y-intercept. That's where this red line crosses the y-axis, and that's going to be at the point 0, 3. Right? The slope is the triangle here between the points. I'm going to go up 3. It's always the rise over the run. 1, 2, 3, 4. Doesn't simplify, so 3/4 is my slope. That means my equation would be y equals mx plus b. Right? Now, the last one, again, the first thing we want to find is your y-intercept. That's here at negative 2. So that coordinate is 0, -2. The m, or the slope, would be a fall of 2 and a run of 6. So -2 over 6, which I can reduce to a -1/3. So in slope-intercept form, this is y is equal to a -1/3 x. Instead of a plus -2, I'm just going to do -2. Right? Notice the patterns. The B is always where it crosses the line, and the M is always the slope. Okay? Now, for the next bit, we just want you to identify your M and your Y intercept. So the slope, which is the M, is the coefficient of the X, -4. I would also accept a -4 over 1, at least for the time being, because slope has two parts, the rise and the run. And if you're just looking at -4, sometimes you forget there's a 1 underneath there. The y-intercept is going to be at 0, 3. Remember, that's your B. Your M is your movement or slope of the line. The B value is the y-intercept. For problem number 2, I cannot tell you the M and the B because it is not in form. I need to rearrange this into y equals mx plus b form. So 3x minus 2y is equal to 4. There we go. I need to isolate that y. So I'm going to subtract 3x from both sides. -2y is a -3x plus 4. And then I'm going to divide everything by a -2. I need to distribute that division throughout my problem, just as I would if it was multiplication. So y is 3/2 x minus 2. So I know my m, or slope, is 3 over 2, and my b, or y-intercept, is -2. So my y-int is at 0, -2. There we go. If we're looking at problem number 3, y equals mx plus b. This is the correct format. I know my m, or slope, is going to be the coefficient of the x, just what's in front of it. So that's 3/5. My b is going to be the -1. So that tells me my y-intercept is going to be at 0, -1. 0? What's a 0? I don't know what a 0 is. All right. If we're looking at number 4, is this in y equals mx plus b form? It is not. So I'm going to subtract x from both sides. And I have a -3y is -x minus 6. And then I'm going to divide each term by a -3, distributing that division just as I would as if it was multiplication. So y would equal, oh, trouble. There's not a number in front of that x. But how many are there? Right here, there's just one x. So this is going to be a -1 over a -3, or 1/3 x. -6 over -3 is a +2. So now I know my m is the coefficient of that x, or 1/3. The b is 2, so my y-intercept is going to be at the point 0, 2. Right? A little bit of practice there, because we're going to keep using this part. We're going to keep using this part to graph the actual lines themselves. Right? So given the equation of a line in slope-intercept form, we want to use this information to graph that line. So here we have y is equal to a negative x plus 2. If we look at this in slope-intercept form, y is equal to mx plus b, we see that our m is going to be a negative 1, or, so that you can see all the parts, a negative 1 over 1. Right? That's the same as negative 1. The b value is 2, which means we need the point 0.02. So here's how we graph the line. Beginning at 0.2, I'm going to plot a point. That's my beginning point. I'm going to use the slope to move to the next point, which in this case would be a fall of 1 and 1 to the right. So I'm going to fall 1 and move 1 to the right. Now, I believe for WebAssign, this is all you need. You just plot that first point, go down 1 over 1, plot that second point, and the line will show up. Sometimes when we're doing this by hand, though, we just keep building. Down 1, right 1, down 1, right 1, down 1, right 1. Okay? This will then give me the graph of the line. Notice that the slope of this line falls, and I had a negative slope. So that matches. I've got a falling slope and a negative 1 as my slope. So I know that that's together. All right. I have used the slope-intercept form, y equals mx plus b, to graph the line. Quick and easy. It's so much better than that table that we were doing. It's so much faster. But there's a lot more moving pieces. Like, you have to know how to do a lot more here. So problem number 2 is 2x minus 3y equals a negative 9. It needs to be in the form y equals mx plus b. Then I can tell you what the m and the b are. In this format, I cannot. So I need to take 2x minus 3y equals a negative 9, and I need to isolate the y. I've got to solve this for y. All right. Oops. So I'm going to subtract 2x from both sides. This gives me a negative 3y is equal to a negative 2x minus 9. Now to isolate the y, I'm going to divide everything by a negative 3. So we have y is equal to 2/3 x plus 3. From here, it is now in that form, y equals mx plus b. I can see my m is 2/3 and my b is equal to 3. So I'll need the point 0.3 for my y-intercept. Beginning at 0.3, so I'm going to plot that 0.3. And then I'm going to use my m to move to the next point, which is 2 over 3. The slope is 2 over 3. So that's a rise of 2 and then right 3. A rise of 2 and then right 3. And with that, I should have enough points to plot the line. Good deal. Once again, in WebAssign, I believe you only need to do a second point and not a whole bunch. Number 3, y is equal to mx plus b. I can clearly see it is already in that form. My m is going to be 1 over 2. The b value is a negative 3, which means I need the point 0, negative 3 to begin. Beginning at 0, negative 3, and then I'm going to move up 1, right 2, up 1, right 2. Keep going from there, plot the line, and we're good. Once again, I believe in WebAssign you only need 2 points, so don't worry about trying to get all of them on there. Problem number 4, this is not in y equals mx plus b form because the y is not isolated on one side. So I've got a little bit of prep work to do. X plus 2y is equal to 10. I am going to subtract x from both sides, negative x plus 10, and divide each term by 2. Y is equal to a negative 1/2 x plus 5. I can tell that my slope is a negative 1/2, and the b value is at 5, so I'm going to begin at the point 0.5. So 0.5 to begin, And then I'm going to, the slope is a negative 1/2. So I'm going to fall 1 and go right 2. Fall 1 and go right 2. There we go. Once I have that done, I can plot that graph. Great. Okay. So using the slope-intercept form, you can see how much faster it is to identify the main characteristics of the line, the slope and the intercept. That using that particular efficiency, let's look at parallel and perpendicular. So now, given parallel line, or given pairs of lines, I don't know if they're parallel or not, but given pairs of lines, we can quickly identify the slopes. So I want a new color. Take a whiff. Take a whiff. Smell a smell. Sniff a sniff. Take a whiff. All right. You probably don't know what that's from. So if we have this pair of lines, let's look at the slope from the first line. This is already in slope-intercept form. So I know the slope from the first line is going to be a negative what? What number's in front of here that we never write? Negative 1. The slope of the second line also appears to be blank, but there is a 1 in front of that x. So my m sub 1, my m or slope from the first line is negative 1. My slope from the second line is 1. Are these two lines parallel? If they're parallel, the slopes have to be exactly the same. That is the same number and the same sign. These are the same number, but they are not the same sign. So they're not going to be parallel. Are they perpendicular? If they're perpendicular, then the slopes need to be opposite signs, one positive, one negative, check. And the slopes need to be reciprocals. That is the flip of the fraction. So 1 and 1. I'm not sure if those are. If you're not sure if a pair of slopes are perpendicular, the check is that m1 or m sub 1 multiplied by m sub 2 has to equal a negative 1. If that is true, then we are perpendicular. Since negative 1 times 1 does indeed equal a negative 1, we can say that m sub 1 is perpendicular to m sub 2. Keep in mind that the symbol for perpendicular is that upside down T. So these two lines are perpendicular. Catching. There we go. All right. If we look at problem number 2, these are great, but they're not in slope-intercept form. 2y plus x is equal to a negative 4. So I'm going to rearrange this by subtracting x. So 2y is a negative x minus 4. And then dividing each term by 2. So y would equal a negative x over 2 minus 4 over 2, which is 2. Now I can determine that this slope is a negative 1/2. Similarly, I have x minus 2y is equal to 0. I need to put this into the same form, slope-intercept, to be able to tell anything. So negative 2y is a negative x. And then I'm going to divide both sides by negative 2. So I've got a negative x over a negative 2. Y would be x over 2. This means my slope, is just going to be 1 over 2. These two are the same, but one is positive and one is negative. Since they're not exactly the same, they can't be parallel. If they were both negative or both positive, we would say parallel. One positive, one negative means nothing. Now, if I want to, I get a negative 1 when I multiply them together? Well, 1/2 times 1/2 is 1/4. So I'm not going to get a negative 1. This is neither. They match neither description. Parallel lines, the slope has to be exactly the same. Perpendicular lines, they either have to be opposite in sign and reciprocals, or they got to pass the multiplication test. Neither of that happens. If we look at problem number 3, The slope of the first line is 1/3, 1/3. The slope of the second line is 3. These, or I guess you could say 3/1. That works. Okay. These two slopes are not exactly the same. 1/3 and 3/1 are not the same number, so they're not going to be parallel. They are reciprocals. 1/3 and 3/1. That's a flip of the fraction. But they're not opposite in sign. If I multiply them together, I get a positive 1, not a negative 1. So these two are also neither. Okay, great. Let's try number 4. Number 4 is not in slope-intercept form. Number 4 is in standard form. So I've got to take my 2x plus 3y is equal to 6. I got to solve this for y. So I'm going to move that 2x over. 3y is a negative 2x plus 6. And then I'm going to divide each term by 3. So y would be a negative 2/3 x plus 2. This tells me that my m is a negative 2/3. It's the coefficient of the x. So my m from the first line, or m sub 1, is a negative 2/3. My second line is 3x minus 2y equals a negative 4. This is not in slope-intercept form. I'm going to need to rearrange this. So to solve it for y, I'm going to move that 3x over. Negative 3x minus 4. And then divide everything by a negative 2, distributing that division just as I would. Negative 3x over a negative 2. Negative 4 divided by a negative 2 is a positive 2. This will, it keeps glitching. There we go. Okay. So the negative over negative is positive. Y is 3/2 x plus 2. So my m here is 3/2. Okay. These two are not the same. These two slopes are not the same, m1 and m2. They are reciprocals. Look at that. 2/3, 3/2. So they do meet the reciprocals, and one is positive and one is negative. So they could be perpendicular. If I want to check that, is a negative 2/3 multiplied by 3/2, 2/3 times 3/2, is a negative 6/6, which is indeed negative 1. So it works in the multiplication test, and that tells me that m1 would be perpendicular to m2. I'm going to put that in a box so I can find it. There's a lot of work there. Okay. All right, 2 more. Problem number 5. Y equals 2x. That's y equals mx plus b. That's in the right format. So m is equal to 2. M sub 1 is equal to 2. The second one, y is equal to 2x minus 1. My m sub 2 is also equal to 2. Do you see how they're equal? m1 is equal to m2, which means that the slope m1 would be parallel to the slope of m2. When they're equal, you have parallel lines. So here we go. Problem number 5, all the way in. We finally got equal. Whew! Took a long time to get parallel. All right, what about number 6? Number 6, we're still in ax plus by equals c. So we got to change the format. 2x plus 5y equals a negative 15. I've got to isolate the y to get it into slope-intercept form. 5y is a negative 2x minus 15. Divide everything by 5. I get y is equal to a negative 2/5 x minus 15 over 5, so that's minus 3. My m here is a negative 2/5, m sub 1. The second line is 3x plus 4y is a negative 15. Or 4y is a negative 3x minus 15. y would be a negative 3/4 x minus, I don't know what 15/4 is. I'm just going to keep it 15/4. That's fine, because I only need the m. M sub 2 would be a negative 3/4. Negative 2/5, negative 3/4. They are not the same. They are not reciprocals. They're not okay. Slow it down, Amy. They are not the same slope, so they will not be parallel. In addition, they are the same sign, so they cannot be perpendicular. These are neither. If you want to check them, multiply them together. Negative 2 times a negative 3 is a positive 6. 5 times 4 is 20. Negative 6 or positive 6 over positive 20 is not going to give you a negative 1. If lines are perpendicular, their slopes will multiply to give you a negative 1. Not happening here. Okay? All right. Whew. Applications. That's what we've got left. I've got 2 applications to do. So let's see how we goes. We're going to use slope-intercept form to write an equation to model this data. BBB, Beer by Bike Brigade, which is local, ordered tumblers from Identity Works that will be sold at Java Vino. The cost of a single tumbler is listed as $28. To encourage large orders, Identity Works offers a discount of 5 cents for each tumbler that is ordered. So we're going to write a linear equation that represents the cost of a tumbler C if the number of tumblers sold is N. Okay, so part A is a little rough, but let's see what we can do. The cost of a tumbler is going to be $28. We know that. That's our start. We're starting at $28. And we're going to take off discounts. We're going to take off. If it's a discount, if we're taking it off, then we're subtracting 5 cents for every tumbler ordered. 0.05 per tumbler. Okay. This is not an equation. It's just a way that I work when I abbreviate things. And I sort of do the words first and put them as succinctly as I can. So the cost is $28 minus 5 cents per tumbler. They want us to write a linear equation that represents the cost of a tumbler C. So instead of cost here, I can put C. Right? And the number of tumblers sold is N. So that number sold could be the per tumbler there. There we go. I have C is 28 minus, because it's a discount, 0.05 N. Beautiful. That's an equation. C is equal to 28 minus 0.05 N. All right. Part B says determine the cost of a single tumbler if they purchase 60 or 120 or 200 tumblers. So what they're doing here is they're asking us to find the cost for 60, 120, and 200. Right? So this is like creating the table. C would be 28 minus 0.05 times 60. Using my handy dandy calculator, 28 minus 0.05 times 60. And I get 25. So what does this mean? If they purchase 60 tumblers, the cost is $25 each. So it's a discount. So if they're going to go ahead and purchase 60, then they'll take $3 off each cost. All right, that's good. What about for 120? What does that work for 120? For 120, that would be 28 minus 0.05 times 120. So 28 minus 0.05, whoops, delete, times 120, and we get $22 each. So if they bought 120 tumblers, then they would be $22 each, which makes sense, right? That's the way most things work. The more you buy, the less you have to pay. That's why like LTD and some of those bulk purchasing places do so well. What if they bought 200 tumblers? So that would be $28 minus 0.05 times a purchase of 200 tumblers. So now I'm going to do 28 minus 0.5 times 200. And then the cost would be 18. So if they purchase 200 tumblers, then they get $18 each. All right, so that's part B. I found each. So this is the number of tumblers, and that's the cost. 120 tumblers is a cost of $22 each. And if the tumblers number 200, then the cost is 18 each. Okay. All right, so that's part B. Part C says to graph the equation. That's why the graph, lovely, lovely graph is here. All right, so I need to go 60, 120, 200. I need to figure out how to put this on the graph. It looks like the number of tumblers will go across the bottom here. And to do this, I apparently need to get up to 200. So to get up to 200, where am I? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Oh, I've got 20 across. I can just go by tens. I'll just go by tens. So 10, 20, 30, 40. We'll make that 50. 10, 20. This one will be 100. Apparently, I need a drink of water. This will be 150. And this one will be 200. Okay. So this will be our number of tumblers ordered. And then our cost will go up our y-axis. And we've got to be able to hit 25, 22, 18. We got to start at 28. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. I've got 15 to work with. So if I go by twos, 15 times 2 is 30. So if I count by twos, I'll have enough. Okay. 2, 4, 6, 12. This should be 18. This should be 24. And this should be 30. Okay. And this is cost in dollars. Okay. So we've got the cost in dollars. All right. So essentially, we've got 3 points we can plot. We know if they were $60 tumblers ordered, so that's 60. The cost was $25 each. So I'm going by twos, remember. So 25 would be in the middle. And if there were 120 tumblers ordered, then the cost was $22 each. So that's going to be 24. Yep, that's going to be right here. That would be 22. And if there were 200 tumblers ordered, that would be $18 each. Oh, that one's spot on. Okay. What happens if they ordered 0? If they ordered 0 tumblers, wasn't the cost $28? I mean, that's just sort of like their stated cost. So if they only buy one tumbler, then they're paying $27.95, which is essentially $28 anyway. So it may not be totally reality-based, because if they were buying one, it would probably just be 28, but not to mention, we could determine how many you had to order for them to be free, because eventually this is going to hit a number of tumblers with zero cost. So real world style, there's probably a limit here, right? Like they probably wouldn't go much beyond maybe $12-ish or so, maybe. I suppose it depends upon how many you order, because, you know, in the business world, the more you order, the less it costs to produce each item. But we don't want to get to a zero. There's probably a leveling off point that is not being considered here, because sometimes those real situations are just more in depth than we are going to go. All right, second example. Okay, I got it. Here we have a florist that charges $25 for basic arrangement of half a dozen flowers, plus $5 for each additional flower. We want to write a linear equation that will represent the cost of the arrangement A if the total number of flowers in the arrangement is a lowercase f. And then we're going to determine the cost of the arrangement if there's 9 or 12 or 24 flowers. And we want to graph that equation. Okay, so here's what we're going to do. The cost of the arrangement, let's start out with part A. The cost of the arrangement is going to begin at $25 plus $5 for each additional flower. Okay. Now, let's see. The total cost of an arrangement, A, the total number of flowers in the arrangement is F. So it's important to note here that F is the total number of flowers. F is the total number of flowers. It's not the additional number of flowers, it's the total number of flowers. So if it were just additional, I could just do starting at 25 and then 7 flowers would be 30 and 8. So yeah, but that's not the case. Our F here stands for the total number of flowers. So if there's 9 flowers in the arrangement, you're getting charged $25, but then only $5 for 3 of them. $5 extra for 3 of those. So if I start with 9, the first 6 flowers aren't going to count. The first 6 flowers aren't going to count. So the cost of the arrangement A is going to be $25 plus $5 times the number of flowers, but without the first 6. So that would be flowers without the first 6. And since the total number of flowers in the arrangement is F, okay, I like it so far. Now I want to simplify this linear equation. So I'm going to do 25 plus 5F minus 30. I'm distributing. So I'm going to get 5F minus 5. So the cost of this arrangement would be 5 times the flowers plus or minus $5. Okay. All right. So that's part A. This is a linear equation. I have 2 unknown variables. Part B says to determine the cost of the arrangement with 12 or 9, 12, or 24 flowers. So what happens when the F is equal to 9? What happens when the F is equal to 12? And what happens when the F is equal to 24? When f is equal to 9, the number of arrangements would be 5 times 9, or sorry, the cost of the arrangement would be 5 times 9 minus 5, which is 40. This gives us a point at 9, 40. If there are 12 flowers in the arrangement, then the cost of that arrangement is going to be 5 times 12 minus 5, or 60 minus 5, which is 55. This gives us a second point, off the mark. This gives us a second point at 12 flowers, cost $55. The third is at 24 flowers, or 2 dozen. So the amount of the arrangement would be 5 times the $24 minus 5, or 120 minus 5, which is $115. So at $24, the cost is $115. Okay. Part C says to graph this. This is the same graph as last time, the same blank graph as last time. So I know the number of flowers is going to go across the bottom. And I know there are 20 spots, and I need to get to at least 24. So I'm going to count by twos. 2, 4, 6, 8, 10. 2, 4, 6, 8, 20. 2, 4, 6, 8, 30. 2, 4, 6, 8, 40. Okay. And then the cost, I know that there are 15 here, and I need to get to at least 115 because that's my highest Y, or my highest vertical value. So this is going to be cost in dollars. And I think I'm going to count. I think I'm going to count by tens, because if I recall, there were 15. So 10, 20, $30, 40, 50, $60, 70, 80, $90. That'll give me enough room. This will be 120. And then that's all the way up to 150. So that gives me enough room. Okay. So now I can use these relationships that 9 flowers cost 40, 12 flowers cost 55 to plot my points. So 9 flowers cost $40. 12 flowers cost $55. And 24 flowers should cost $115. So there's 22, 4. And then I need to get to 115. And since I counted by tens, that's going to be directly in the middle. And those 3 points beautifully line up, so I know I have the correct graph. And this would be a graph of my line. Okay. What does it mean that this doesn't start at 0? What does it mean that it starts at essentially 1 flower? 1 flower is not $25. Oh, you know what? The first 5, this will look different. 1, 2, 3. The first $5 are 5 flowers. First 6 flowers. So 2, 4, 6. These would all be solid because it's going to be 25 for the first. I don't want this part of the graph. There we go. The first 6 flowers are all going to be $25, whether I get 1, 2, 3, 4, 5, or 6. So I could keep it straight there and then curve it. It really doesn't start till 6. Right? Okay. All right. So in this presentation, we took a look at 5 different goals. We used the slope-intercept form of a line to identify both the slope and the intercept. We were able to write lines in slope-intercept form when given the slope and intercept, and we used the slope and intercept to graph the equation of a line. We looked at slope-intercept form as a way to tell whether or not lines are parallel or perpendicular. And we wrote some application equations in slope-intercept form and then graphed them by plotting points. All right? If you have any questions, please don't hesitate to reach out to me, Amy Fuchsteiner, and the Math Center will certainly be more than willing to help you if you run across anything you need some help with. All right? Thank you. Have a good night.